So additive, subtractive, and inspection products are right there. We're local, we're experienced, and we have dedicated staff. We have offices in Anaheim, Newbury Park, and San Diego. And in all three of those offices, we offer online training, obviously virtual and on-site. So we have those running throughout the year. So we are local. We know the local manufacturing community, and all in all, it's our goal to make your businesses successful. So the closed loop manufacturing process, it's really taking apart from art to part in a unique, efficient, and real world way. This putter right here was actually something that we tested it out with. So we took it into Verisurf and reverse engineered an existing putter head, made some changes to it. We actually printed fixturing with Robos on Carbon PA Pro because it's a relatively unique fixture. And then the putter was printed in stainless steel. The CNC programming aspect, we have CAM Assist, which is an AI tool that can plug into Mastercam as well. We then ran it through simulation in Vericut. We did some probing in Simco, so you get your probing routines in there. And then when it was done, we actually inspected it with Verisurf as well. So we do offer all of these products. We support them. And this is the putter in real life, and it did not help my golf game. So that's kind of my part for right now, and we'll let Rob jump into the Mastercam Deburr.
All righty. Thanks for joining us, guys. So we're going to go through the Deburr program here, and also just want to point out, as you guys know, all of your parts need to be deburred. So, and it can be a daunting task to deburr them on the machine. And hopefully after today, you'll see the advantage of this product. So Mastercam Deburr does allow you to install it on a 2D system or mill and mill 3D. Can be put on router, mill turn, and also lathe. So you can also use your Deburr in without having to use the multi-axis add-on. So we've been having that request for a long time, and here it is. Go to the next slide. Okay. So the Mastercam Deburr, it's simple to use, and you guys will see that in a few minutes here. It can automatically detect all the sharp corners. The user can define sharp corners, can be programmed on 4 and 5 axis machines using 4+1 or 3+2 plane programming. Let's see. Let's go to the next slide, Grant. Let's just kind of move along here. The tools that it does support: ball end mills, lollipop tools, and taper tools with full tip radius. And moving along, staying connected, you can move on to the next slide. We have in Mastercam Connect. Now, you've probably heard of Mastercam Connect over the last few months. Basically, it's maintenance. But the advantage of staying on maintenance is that we released this Deburr toolpath program in 2025 when it first came out. And those were the tools that were supported: the lollipop, the taper with full radius, and a ball end mill. Now, in the latest update 4 in 2025, we now support chamfer mills, dove mills, multi-pass motion for rounds, and chamfers. So pretty much the same controls that you have in your multi-axis Deburr, but locked down to, of course, 3 axis. And then, of course, more tool support to come. Let's see what else you got there. Okay, so that's that's how the tool paths in this program works. Now, I do want to add some additional talking points, and I think this is a really important talking point. Just safety, and as you guys are aware, deburring parts, taking parts out of the machine with sharp edges, having to flip them over, moving it around. First that obviously creates a safety hazard. But also it can create inaccuracies in the part itself, especially if you have to take the part out of the machine to deburr, put it back in the machine for other operations. And of course, dealing with the sharp edges. Also, I kind of did this really quick Google search here on OSHA and found out that companies are losing employees during the week or for weeks due to lacerations and can cost the company up to $46,000 in direct and indirect costs. And I thought that was pretty interesting because, as you guys all know, if you've been in this business for a while, you've probably sliced your fingers once or twice here or there. So obviously can create can create hazards in the workshop. Go ahead and switch it. Okay, so some other talking points. Using hand tools obviously can prolong and lead to carpal tunnel. The biggest hazard of hand tools is just improper maintenance and misuse. That's obvious, and I'm sure you guys have experienced. And then the third talking point here is just the time and cost of an overall dedicated deburring department. If I can do this all in one shot, all on the machine, then this is a hazard that I don't have to pay for or deal with. So is okay. I think this is where you wanted me to go in and demo, right? Or I can't remember when you changed that.
Yeah. Yep.
Okay, so I'm going to demo the product, and then towards the end, I'm going to show you how fast the calculations can be. And then we're going to have a little contest here. We're going to allow you guys to kind of guess how long it would take to deburr a part that's complicated. So this is, if you haven't seen it, we machined this part, this guitar at IMTS, and so this is the bottom half of the guitar body. So you can only imagine how big this part is. Obviously, if you were going to try to deburr this on the machine, it could take hours to program. So when we get to this, we're going to give you guys a chance to type into chat how long you think it'll take, and then the winner wins a prize. So there you go. So let me do a couple of things here. I'm going to share my screen now, Graham. I'm going to run through a few parts here. Here's a typical housing. As you can see, deburring this part, taking it out of the machine and just having to scrape this with a deburr knife could be pretty difficult, especially when we're coming up against walls and very close to floors. I may not even be able to use my deburr tool in this area because it could scratch this floor. So in 2025, and again, this is update 4, in the gallery here, we have the deburr toolpath. And I'm going to grab a ball end mill, and we'll just go through the cut parameters. For the machine geometries, I'm going to select the whole part. Okay, get that triple click. So I'll select the whole part. And the reason I selected the whole part is this toolpath is it's gouge proof. So it's looking at all of those faces or all those pieces of geometry and gouge checking against them. For the edges, we have this auto detect. Now the auto detect can come in and take care of all of the sharp edges. Every sharp edge that it can find. And this may just be enough. However, if I do use auto detect, I can come in here and exclude edges. So if there's edges that I don't want it to find, let's say, for instance, this is going to be chamfered milled. So there's probably no reason to deburr that. So I'm just going to come in here and, oops, hold on. I'm going to come in here and I'm going to grab those edges. Actually, take that back. I'm going to clear this. I'm going to grab all those edges. And I just basically held down the Control Shift and picked those. Okay, so I'm going to exclude that geometry. We'll come back to some of the other settings as we go along here. With the edge shape, just what do I want to break the edge? Let's say 10 grand. Tool axis control. Obviously, it's 3-axis. It's locked to the Z. Linking, I can, I just want to be 1 inch above. There's some automatic settings here. This menu is pretty similar to what you've seen with other toolpaths inside of Mastercam. And some feed rate control. But as it sits right now, I'm just going to hit the apply button and let that run through. And as you can see, that quickly, all of those edges are nice and deburred, gouge checked. You have some control here. We can tighten up if we want to tighten up the radius, maybe get this a little closer for the lead in and lead outs. Again, it'll completely gouge checked on those edges. In the tool axis control, this is where it's gouge checking. Here's your clearances. So I have 100 grand on the holder, 25 on the shank, and 10 on the shoulder. And of course, those can be all adjusted, but going back to your tool, it better be defined properly, and same with your holder to make all of that work. And we'll give it a quick run through here. And again, nice, clean, sharp edges. Everything is consistent. And this is what literally separates one machine shop from another shop. If I sent this out to a customer, he's going to be more happy than if he saw a bunch of scratches on the part and inconsistent deburr operations. This is just clean and gouge free. Okay, so moving on, I'm going to go into my next part here. Let's turn off this guy. So on this part, I have this heat sink. Reason I made this part is obviously heat sinks are nasty, a lot of sharp edges, a lot of deburring. Very daunting if you had to do this in program. Not only that, if you had to program it manually or traditionally, again, we're looking at this and obviously it's a 3-axis part as well. And again, keep in mind, this can be this can be added to a 2D mill or 2D router. So we'll go back into the Deburr. I'm going to switch over my tool. And again, I'm going to grab the whole part. And I'm going to leave this on auto detect. I'll come back to the other option, user define, in a second here. Again, just want to exclude. And again, I'm going to hold down Control Shift. And triple click on that to grab those features. I'll break the edges by 10. And again, let's set the linking. Let's make that like 1 inch. Okay. So I hit apply. And let's get out of here. Oh, I must have left out an edge. No big deal. We'll come back into the cut parameters. Let's just add. Let's add those. Okay. All right. Now, as you can see here, nice, clean, again, gouge free, checking against the other blades. Of course, if I went in with too big of a tool, then it would trim it back. So may not deburr everything because of the gouge checking. So another feature that we have, I'm just going to copy after here, is the ability to use lollipop cutters. Now, this has been a request from 25 years since I've been with Mastercam, that everyone wants to do an undercut with their mill product without having multi-axis. As you know, it's like you can do this with a lollipop cutter, but you'd have to turn off all your gouge checking. We tell you can use contour and surface contour, or you can use flow line with all the gouge checking turned off. But of course, when you turn off the gouge checking, you're on your own. Lead in and lead outs don't happen for you, all that stuff. So with this enhancement, instead of doing the auto detect, I'm going to do a user define here, and I'm going to grab I don't know why I'm grab that. I want to grab that loop. I'm having mouse problems. Okay, I'm going to grab that loop. Again, now 10 thou. Tool axis control, everything's still the same. All I really did here was just switch over to the lollipop cutter, and we'll apply that. And as you can see, a nice, clean, gouge-free undercut. And I can't tell you how many times I've had customers request just to do this. Okay. Now, one of the other advantages to this new update is we now included the ability to put rounds on these edges. So even though I have this part here that is an undercut, this is another feature that you guys have been requesting. If you had a fillet in here, and of course I'm not going to draw in the fillet, I'm just going to tell it that I have a 30 thou rad there, and I'll set that to round, and I'll give it, I don't know, 10 passes. I'll hit apply. And as you can see here, let's just take that in. Okay. So now we can apply those radiuses on those corners. Definitely having mouse issues. On those corners, and again, all gouge free, not a whole lot of work. Obviously, I didn't have to do a whole lot of work to put that in there. Just had to tell it that the size of the rad. So that's enhancement number 1 in the update 4. Enhancement number 2, we can now apply chamfer tools. So for instance, now if I want to come back in here, I'm gonna just do a copy after. I'll kill this, and I'll move over to my chamfer mill. And user-defined edges, I just want to do that loop right there with a 30 thou chamfer. Again, my collision. And I'm going to let that run. It's going to hit the check mark there. So let's take a look at, of course, it's doing the chamfer, but let's look at what's actually happening here. Right in here. Okay, obviously not a good idea. So a way to combat that, I actually have 2 ways to do it. If I don't want to hit this, I'm going to come back in here. And again, I mentioned this earlier, but we do have avoidance geometries as well. So I can tell it I want to avoid that and that. And I want to avoid it by, let's say, 10 grand. And again, there's my avoidance. So obviously, if we did this the traditional way, we would have to trim, we'd have to do all the kind of things to a 2D contour toolpath, which you guys, if you've tried that, already know the headaches. Okay, that's one option. Option number 2 is, I don't want to avoid this. I think I can get in there with that tool. So one of the nice advantage of the chamfer toolpath is I can tell the toolpath where to ride along that edge. Right now it's 50%, it's right in here. If I wanted to go further down, maybe because I want to get onto a larger diameter without having to crank up the spindle speed, that would work. Or in our case, maybe if I just make that 25% and I slide down closer to the tip, and let's just take a look at that. Oh, I don't have my fixture over there. I must have missed one. But as you can see, we can clear it. We've got the chamfer. Both are good options. Obviously, avoidance areas are necessary. One of the ways I could have handled this hole, if I already had the socket head screws in there, I could tell it avoid that. Um, I mean, there's so many options there just to control these tool paths. So again, brand new, and the update 4 is the ability to put rounds and chamfers or chamfer tools, and option or advantage number 3, which is going to be dovetail cutters. So if I wanted to deburr the bottom of the part, obviously the collision is going to come into play here. Without flipping it over, we now are supporting dove tools. So let's just go back in here, select the dovetail, go pick the whole part again. Oops. Let's go user defined. I'm going to use the bottom loop. I'll make it a 60 thou. And of course, I want to avoid that. Okay. And 1 inch, that works. Let's give it a ride. And of course, nice lead in and lead out off the part, off my fixture. Nice clean undercut. And obviously, you may not do this type of operation with this part like this after you may flip it over and do it. Just again, just showing you that option of putting in that 60 thou chamfer with a dovetail cutter. Okay. Let me just open up a file here and show you the chamfers and rounds. So of course I have this tool path and I'm just breaking this edge. And the other edge. But let me show you again in the cut pattern. I set this to rounds, we'll make it an 1/8 inch radius. We'll give it 10 passes. We'll apply that. And as you can see, we have the rounds. Quick way to put fillets on. Completely gouge checked against that edge and that edge. And if I want to change that to be a flat, now I have that machine flat in there. Without having to use the love-hate relationship with Flowline. Pretty easy, pretty simple. And with that, before I go into that other part, Graham, I'm going to ask Dave if there's anything I kind of missed or should enhance.
No, it's pretty thorough. If you want to show something cool, you can slap the blend spline on the linking page. That's
Oh,
pretty
that's
neat.
right.
Yeah, just to show it so people know it.
Yep.
Bottom, yeah, turn that one on.
So
Just
what
take,
Dave's talking about here is in the linking, obviously I'm retracting the clearance, but we have a clearance blend.
yeah, just regen that.
What's up?
Yeah, just regen that. There's no
Yeah.
setting.
And so now we have these nice blended moves across,
And then on
especially if
the
you're running a high-speed machine, you
yep,
know,
and the feed rate control page,
right.
you have control of that feed rate.
You have
Yep.
control here for the blend.
It's-
And obviously you can replace with rapid. I would leave that as a feed rate and then increase that feed rate. So now you're not making sharp, jerky moves with the machine. It's smooth. It's sometimes you'll see that tool path, you know, maybe you'll look at that and say, that looks very strange. I'm so used to just regular retract and rapids, but I think once you've start getting into some of these linking controls and using that blend, especially on your high speed machines, I think you'll enjoy the outcome.
Yep, it's like anything, right? Depends on the machine's capabilities. It's just sending the motion out that your machine wants. You got an older, slower machine, you want those G0 rapids, absolutely. But if you got a fast machine, there's less hesitation here because there are no harsh 90-degree direction changes. The machine just moves real fluid. But the toolpath has the ability to kick out motion friendly for your equipment.
All righty. Graham, did you want to go into questions first or go with that guitar body?
Well, we can answer these two questions while you're opening that up.
Okay.
And then also this guitar body is the one you're going to do your time test on, correct?
Yeah.
Okay. So having seen what you folks have seen, um, if you haven't already guessed how long it's going to take to calculate um, with this guitar body, go ahead and throw that into the chat. But one question we have is, will chamfer mill only work for 2D surfaces?
No. The chamfer mill will work on 3D surfaces as well. As you can see with that last part I had.
Yep. Next question is, will these features work with 2024? And I believe the answer is no on that. So this is released with 2025, and even those new updates are 2025 update 4. So you have to have 2025. One of the benefits of being on maintenance.
Okay. Let's just take a quick look at this guitar body before you guys guess. We look at this thing's roughly 20 inches. We'll call it, yeah, we'll call it 20 inches. So we'll call that 20 inches. Obviously, a lot of edges in here to have to deal with. You can only imagine having to program this traditionally. So what I'm going to do is I'm going to take this into Deburr. And I am going to pick the whole part. And, again, while you're making your decision here, notice that there's 1,859 machining geometries in here. I'm just going to do the auto detect. I'm going to just do all the sharp edges. We'll break it at 10. We'll link it 1 inch. And what I'm also going to do, you'll see once we start this, I'm going to bring up the stopwatch. So, all right. If everybody's made their guess, I'm going to try to be quick here. I'm going to hit the check mark, generate the toolpath. We'll bring up this and we'll start. Yep.
Another question in the chat too, unless you want to wait.
Well, let's run through this first. And again, this is complex geometry. I mean, and again, this would be something you would not want to hand to Burr.
Yeah, it would be awful to scratch this part during the Deburr process.
All right. There's the number. Less than a minute. Nice and clean. And again, I can't stress this enough. Just gouge check. Just a clean toolpath with consistent edges. Did you say there was a question, Bram?
Yes, this is more of a 5-axis, but may as well go after it anyways.
Okay.
When I am using Deburr 5-axis simultaneous, when the tool doing transition, that's a typo, I think it's transition. It has some funky linear moves and sometimes table moves really fast on rotation. Will I check mark on feed rate control to fix that?
You could, if you're linking already, if the links are, I think they default to rapid anyway. So you could put all your retract and links to feed rate and then use your feed rate control. Some machines, if you have like a Haas UMC, they actually do prefer the feed rates for the replaced with, or the rapids replaced with feed rates. And of course, then you can control how fast that move is. So it's machine dependent. You know, if I was going with a Kuma with their super NURBS and all that, well then it enjoys the G0 moves instead of the G1 moves. So it's all relevant to the machine. But if there's something that you want us to really explore for you, feel free to reach out to us at our MC support, and we'll definitely help you enhance that. So. Speaking of the difference, now one thing that Dave brought up yesterday when we were talking is that if you already have multi-axis, obviously you have the Deburr toolpath in the multi-axis suite. But with your multi-axis license, you also get this one in the 3D suite. And the difference there would be if, of course, you can lock your tool axis to 3-axis in the multi-axis toolpath. But keep in mind that's vector based. So the code is going to look more TCP versus the 3D toolpath, which is an actual clean 3D toolpath. So that's the difference. If I was running this on a standard 3-axis machine, this is going to give it better output than trying to use the multi-axis locked at 3-axis.
Josh had a good question about would it be better to not have any of the chamfers or edge breaks drawn in the model, modeled into your solid, right? And the answer is an absolute yes, because this toolpath detects the sharp edges. So if you have chamfers already, it's going to detect the top and bottom sharp edge of that chamfer. Now, there is a filter in here to try. There's more to this than we can't demo all of this, but there is some angle detection limits. But to your point, if you stop and think about that, if the answer is yes, then there's less work up front in the CAD model. You don't have to model those fillets. You don't have to model those chamfers. There's value in not having to model those shapes if you're in control of that internally at your company, right? And if a model comes with chamfers on it and rounds in the areas that you desire to use this toolpath, don't forget Mastercam has powerful model prep editing tools where we can remove the chamfer and restore the sharp edge. We can remove the fillet and restore the sharp edge. So yes, the sharp edges make this toolpath easier to use, and at the same time, there's less work to do on the CAD side.
That's a good point. Yeah, the other one was, can this tool generate a 5-axis toolpath? And Rob kind of addressed that earlier.
Yeah,
Yes,
there
this
are
has
two.
been. Oh, go ahead. Sorry.
Yeah, there are two versions of it, right? The 3-axis is that's the new product there, and then the 5-axis has always been included with a multi-axis license, and that product there has a very different tool axis control page. You can do 3-axis, you do 3+1, 3+2, simultaneous 4, 4+1, and simultaneous 5. So there's a lot of horsepower in the multi-axis version of this. The difference with the 3-axis here and the Deburr 3-axis version of the toolpath is in your NC output, like Rob was saying. You're going to get more of a TCP format to your code when you use the 3-axis version of the 5-axis Deburr. When you use the Deburr 3-axis toolpath, your G code, your NC file is formatted to reflect more of a tilted plane style of code. So they are different. And sometimes we experienced it recently. A multi-axis customer actually preferred the formatting of the Deburr 3-axis, even though they were on multi-axis equipment. So it's kind of like you can have it your way. Two different ways to get 3-axis output, whatever you want. Just like the Rapids, have it your way. Do you want G0? Do you want a blend spline? What does your machine want? What's your personal preference with the way you're looking and reading the G code? So there's a lot of flexibility here.
Yeah.
Yep.
Awesome. Thank you.
So obviously, in this Deburr toolpath, I 3-axis is the only output.
Yeah. And this is a very different version of that 3-axis output. This is a tilted plane approach to the code output.
Mhm.
So
Hey, what paperwork do I need? I gotta go.
Also, here's the edge treatment stuff that Dave was talking about. So you can control some angles there. Obviously, the beauty of this is if you do make changes, you saw how fast that calculates. You know, Mastercam's come a long ways. I mean, I am just impressed with how quick and easy I get toolpaths presented to me. God, it used to be so hard just to sit there and wait and then have to change and come back and wait. Now I don't even have to leave the page, just hit the apply button. I mean, that's huge. That's been a huge benefit in Mastercam for the last couple of releases. So advantages of staying on maintenance, staying now connected, if you will. It's just, this stuff just gets faster. You may not see a lot of big changes in the software and think that it's not a reason to update. But I guarantee you, one of the biggest reasons to update for me is the fact that it's just fast. I can show you all of these parts, and we did it in less than an hour. I couldn't have done this, but the way it calculated, 5, 6 versions ago. So definitely an advantage. Time is money. Time is always money.
All right, got some other questions coming in here. Well, just the one that Dave answered. So was Lollipop using gouge check on the backside? What about using a back corner rounding mill? And Lollipop does support full gouge check, no radius mill support.
I'm sorry, what style tool?
He's asking about a rad mill.
Oh,
Yeah, a backside, I guess a backside rad mill, but no, the rad mill is not supported.
yeah.
I mean, a rad mill would only be useful for planar edges, regardless, but it's not supported today.
But you still have that option.
Absolutely, and that is fully gouge checked and safe.
Yeah.
Yep. So I get it. The rad mill is enticing because it's a single swipe, right? But no, it's a rad mill can't do this anyway. You can't use a rad mill in 3D. It won't compensate accurately. But you take those multi passes and have one smooth, perfect radius under there as opposed to doing it by hand.
Yeah.
Yeah. I mean, it's like you got to pause. Oh, there's multiple passes. It takes more time. Okay. Not really. No, it doesn't. Not in the grand scheme of things. That's a lot quicker than you'd ever put a round under there. And you'll never, ever, ever, ever put it on there accurately by hand. It's impossible.
Yeah.
Unless you are amazing. That's a consistent rad right there.
I
And
got
usually
a
you're not
question.
making one heat sink at a time.
I got a question for you, Dave. Any chances we can get this as a zigzag motion?
Yeah, well, we've had some discussions with them about cut order and such, and right now the cut order is controlled with the toolpath, but everything's on the table. Like people have asked about inside out cut order or outside in cut order.
Yeah, I was going to ask you that
There's
too.
none of those complications are in this toolpath quite yet. And the other thing that comes up a lot, we'll just head off a question, is if you're going manual, and you saw, Rob showed you how you can just pick the edges you want to machine. So if you picked a number of edges in a certain order that you desire, it will not always machine in that order. And you have to understand that this toolpath needs control of the cut order to make sure that it can do things safely. Because if you're coming up to a vertical edge and you're machining that way, it has to understand, well, has that vertical edge been deburred yet? Like you can see the vertical edges on this part, on his outside have a little bit of motion because the ball end mill can reach down there on the outside of his part, on the outside of his block. So if you're coming up to that, like a boss with sharp edges, and then you're chamfering toward it, well, the software might say to itself, well, if I machine the vertical edge first, then the horizontal edge can get even closer. I can cut more of it. So there's a lot happening with the cut order. So there's no explicit control yet. Let the toolpath do its thing. And you can see, I mean, look at this. It's not like it was jumping around. It was pretty consistent there. But there are times where you might want to hold its hand and say, go here, then here, then here, then here. It might not follow that. But it's not going to do something like in this example here, crazy and just bounce around. It needs control of the cut order to ensure that everything is safe. Because it knows, well, like, this is a tight part here, and it might be in a situation where when it's cutting one edge, it could be hitting another edge, but it's you have to give it freedom to have cut order control. But we have discussed that, especially like you said, the cut order with the multi passes. It would be nice to say um, out in out at least, and zigzag, but not yet. That's not the focus of the core tech is the focus on this toolpath, making it safe, making it reliable, and to be quite honest, just don't want to overly complicate it with settings. Keep it simple. Keep it very simple. But the color thing could make sense, like the in, out, out, in. We can totally understand that relevant to tool wear and what part of that ball you're cutting with. You want to cut with the the deeper gullet of the flute. Sure, maybe you wanted to go in, out, or out, in. But nothing yet. But it usually does a pretty good job with the cut order, and everything is safe.
Another question here, a couple. There's a price question, and we'll talk about that in a moment. If the fillet runs to the edge, how will the chamfer look?
Say that again.
If the fillet runs to the edge, how will the chamfer look?
The fillet runs to the edge. Oh, down. I'm not. You mean on up here? I don't know where we're talking about.
All right, well, Juan, you can shoot us an email about that. What if the edge break requirements are different from edge to edge within the same part?
So this part here that I did, obviously I put 10 grand on these edges, and then I did put a chamfer here that was 30,000. I put a chamfer down here that was 60. So obviously the way to accomplish that is to just copy the toolpath and just select the geometries that you want to machine with those settings. And this pretty much has all of that, right?
That question has come up, yes. And if you take pause for a moment there, right? You could imagine the interface, right? Now I have to somehow say automatic. And like the exclude edges, you have to have some way to manage these custom edges. And you got to pick them all, put all your values. So the toolpath gets complicated. And you run it and you process it and you get it. That's pretty involved. When today it's just, yeah, I get it. It's a separate toolpath. But in that moment, you do have explicit control of all the other settings that you might want to change depending on the size of that edge treatment. Who knows? You might want to change a different lead in, different lead out, or something. But we've explored it, and it gets very, very. It's almost like we would overly complicate this toolpath for the sake of having one toolpath in the op manager. When in the end, it's not doing anything to make your G code more efficient. I mean, 3 toolpaths or 1 toolpath, that means nothing to the NC output. But having one op support all that custom definition per edge is very complicated. So we've kind of put that to the back burner in our head, but people have asked it a few times. So we continue to put thought into it, but there are no plans to go that granular.
So as Rob said, basically every part needs to be deburred. It eliminates the need to hand deburr, saves your hands. This is pre-existing in multi-axis, but now it's available for mill router, the 3D versions, and mill turn. So I think that answers one of those questions in there. This can be used in lathe if you have a mill license as well. This is a purchasable product. Couple of questions in there. So roughly it's going to be about $2,000 for perpetual, $800 for subscription. And then if you're current on maintenance, you can purchase this, use it on 2025. And you saw the updates that they included in update 4. So just another reason to stay on maintenance. So just closing up, you can find us at our website, CAD-CAM.com. Of course, as the marketing person, I recommend you to sign up for our newsletter. We come out with them quarterly. Mastercam.com is the corporate website. Any additional questions, you can reach out to marketing at CAD-CAM.com. If you want a demo, you can email us or find the form on our website. Both of our companies are all over social media. We will record this, so that answers another question, and put it up on YouTube. And that will go on our new playlist called CAD-CAM TV, just released a few weeks ago. It's really just our folks giving you free tips and tricks, and we're releasing videos every single week. We're also, trying to keep them relatively short and sweet, tech tips, and we're going to put all of these webinars up there. So for the next one, we're going to be looking at Simcoe on January 14th, same time. So once we get this recording all rendered and ready for prime time and uploaded, we'll send out a link to that as well as our next round of invites for Simcoe. And we're going to be doing this every single month, and it's really going to be focused on the products that we offer. This was in Zoom, but we might be switching to Microsoft Teams. That's a good problem to have for us because we had a lot of people sign up for this, so we're almost at our limit. And we have a little bit more in terms of participation ability in Teams. You can take these down, screenshot them, send us an email if you have any questions. And we can just take a look for a few more minutes at any additional questions. I think we addressed them all so far. All right, what if a finished part does not meet the 3D model anymore due to a part being a large part and removed a large amount of material has moved the features or edges around? You guys might need to read that one.
I mean, he's talking about standard machining, right? If you have to think about how you remove large amounts of material because your part moves, it's not magically going to know where the part moved, right? So you might just think about the order or how aggressive you are removing that material as you move along. It's a complex thing there, but a very real thing. Parts have spring back and they do move. So that's more of just a technique in how you approach machining that part and how you choose to remove that material, so that the part edges don't move.
And this doesn't have to be the final toolpath.
No,
So,
not at all. You can, as soon as those edges are exposed, you can deburr them before you
right.
remove a chunk, and those two things are going to flex out a little. Yeah, that's processing a part in a proper way, I guess.
Did anybody come close to 54 seconds?
Yeah, there's a couple. So I've messaged the person that came the closest, and they will email me, and we're going to send out a little care package.
What was the high-low?
I think the closest was a minute 10. Then we had some people guessing 3 seconds, 6 minutes, 15. So we had quite the range.
Yeah. When at IMTS, we played this game with this exact same part, and I don't think anybody guessed under 3 minutes. And I guess their computer was a little faster because it processed around 36 seconds on the show floor. So
there actually was one additional question about the guitar part itself and seeing that simulate. I think that's on the Tech Exchange on the Mastercam website.
So not fully.
No.
No. The actual part itself is not there yet. I talked to Dave Miller about it, and they're kind of cleaning it up a little bit right now, but the only thing that's on there on the Tech Exchange is a tool list that they used. So,
Gotcha.
I mean, keep checking. That at some point, I'm sure he'll put it up there. It may already be up there. I don't know. I talked to him last week.
All right, last question we're gonna take, then we got to bail. Do you know how long it took to machine that part, the guitar part?
Huh, huh, the guitar part. Yeah. Oh God.
That was titanium, correct?
That was aluminum.
Was it
I
aluminum?
believe they're going to do one out of titanium. I think like the neck, one piece, and it's like machining a tuning fork, basically, right? Um, I think that alone took over 50 some hours of machine time. The machine time was intense on that part, but you don't appreciate it until you get to hold it in your hand and look at it with your own eyes. The finish is just absolutely amazing, considering how thin that is and everything. Yeah, the machining time was intense on all those parts. That was just the neck.
Oh, so the question actually is clarified. Just the deburr tool path. How long would that take?
Oh, I'm not sure
Yeah.
what feed rates they ran, but I mean, just looking at it here, it doesn't, that doesn't look so bad. That's the beauty of the Deburr. It's never a lot of motion. It's never intense with motion, especially when you're just single swiping. So
Okay, well, I think that does it for us. Thank you everybody for coming. Happy holidays, and thank you, Dave and Rob, for doing the demo, answering questions, and
yeah.
just being available.
Thanks, guys. It was fun.
All right. Well, have a good day, everyone. Thank you.
Yeah. Thanks, Dave.
We'll see you guys.